Okay, this is our Unit 1 test over functions, domain and range, inverse, and linear regressions. Okay, so for the first one, we're going to write the domain and range of this right here. Okay, so remember, domain goes from left to right, and then range goes from low to high. Okay, so if I'm going to write it like an inequality, I know I'm going to have this in the middle. Okay, so I'm going to take a look here. Now left to right, I notice this goes down, but it's also going to the left, and this goes up, and it's also going to the right. And it has arrows, so I know it's going to go on forever. So that's going to be negative infinity is less than x, which is less than infinity. For set notation, I'm going to use those squigglies. It's domain, so I'm going to use the x, and I'm going to draw the line. And then again, it's negative infinity is less than x, which is less than infinity. Alright, for interval, because it's infinity, it can't be equal to it, so I'm going to use the parentheses. And there you have it. Okay, now for range, for low to high, again, it's going low forever. So negative infinity is less than y, that should be a y, because it's range, which is less than infinity. Okay, for set notation, I'm using y. And then I'm doing pretty much the same thing I did with the inequality. So negative infinity is less than y, which is less than infinity. Alright, and again for interval, because it's infinity, it can't be the brackets, so it's going to be the parentheses. Okay, on the next one, same thing. Now this one does not have arrows, so I will not be dealing with infinity. I'm going to number this graph a little bit just so it makes, can you see a little bit better. So there's 2, 3, 4, 5, this is at 6. This is 0, 1, 2, 3, 4, 5. This is at 5. Okay, and it's on the negative side. Okay, so for the inequality, again, it's left to right. So this goes all the way to the left to negative 5. So negative 5, and it's a closed dot, so less than or equal to x. And then it goes all the way to the right till we get about right here, and that's going to be 3, 4, 5. Less than 5. And the reason I'm using the less than sign here is because of that open dot. Okay, set notation, again, I'm going to use those brackets. And then negative 5 is less than or equal to x, which is less than 5. And then for interval, I'm going to use the bracket here because of the closed dot on the negative 5. But then I'm going to use a parenthesis on the other side because of the open dot at 5. Okay, for range, low to high, the lowest it goes is 0. So 0 is less than or equal to y. And then the highest it goes is 6 here. It's an open dot, so just less than 6. For set builder, I'm going to use those parentheses. I'm doing y, doing the range. And then 0 is less than or equal to y, which is less than 6. Okay, so interval. So again, I use the less than or equal to. So here I'm going to use a bracket. And then I'm going to use a parenthesis at 6 because of the open dot. And again, remember range is low to high. Okay, on this one here, again, you have domain. Again, it goes left to right. And then range goes low to high. So for the domain on this one, I notice that it's going down, but it's also going to go to the left because of the arrows. And I notice this is going down, but it's also going to the right. So for inequality, it's still going to be negative infinity is less than x, which is less than infinity. For set notation, I'm just going to rewrite that. And then for interval, again, we always use parentheses on infinity. And you kind of think of it this way, there's a curve on the infinity, just like there's a curve right here. Okay, now for range, again, I'm going low to high. Now notice this has arrows at the bottom, so it's going to go low forever. So negative infinity is less than y, and then it goes all the way up to here to 3, okay, so less than or equal to 3. Set notation, again, doing the range, I'm going to use y, and then I'm just rewriting what I had for the inequality. Alright, for interval, I'm going to use a parenthesis on this side because of the infinity, but then I'm going to use a bracket on the other side because of the closed dot right there. Okay, so write the domain and range in interval form for the function y equals 2x. Well, hopefully by now you know this is going to be a linear equation with a slope of 2. It goes through the y-intercept because your y-intercept is 0, plus 0. Now, because it's a line, that means it's going to go left and right forever, and it's going to go low to high forever. So if I write this in interval form, I'm saying the domain is negative infinity to infinity. And again, the range is negative infinity to infinity. Now, sometimes on the graph, it'll have points like this. You need to ignore those points. Ignore them. The only thing you need to focus on are where those arrows are going. All right. Okay, on this one here, it says write a linear function to represent the data in the table, round to the nearest hundredth. So the first thing you need to do is you need to get your calculator. Okay, and I'm going to go to Stat Edit. Okay, so I'm going to go to Stat, I'm going to go to Edit, and then I'm going to clear out what I have from previously. Make sure you don't delete them. You have to have the L1, L2. And then I'm going to start inputting all this information. So I see that I have 85. Well, that light didn't make it too much better, did it? Okay, so here I have 85, I have 71, 84, 66, 77, 75, 68, and I have 91. Okay, now I'm going to come over to L2. I have 200, 160, 170, 120. I have another 120. I have 180. I have 100, and I have 230. Okay, so from here I'm going to do Stat, Calc, go down to number 4, keep on hitting Enter, and there's my equation. Now notice I already have my coefficient of determination, but I don't need it right now. So right now they just want me to write a linear function, so that's y equals. They want me to round to the nearest hundredths. So if I round to the nearest hundredths, I'm going, oops, that's going away. Okay, so if I round to the nearest hundredths, I'm going to look at the thousandths place. That's a 3, so this stays 4.19. And then for my b, I see negative 163.410. So because there's a 0 in the thousandths, the 1 will stay the same. So minus 163.41. Okay, now they want me to predict the ice cream sales if the temperature was 97. So just because your calculator gives you this information does not mean that it can just automatically give you the thing in the table. So here what I'm going to do is I'm going to go to y equals, and I have to type this in. So 4.19x minus 163.41. I'm going to go to my table. They want me to predict the ice cream sales. The sales are your y if the temperature is 97, and that's your x. Okay, so I'm going to come down here, and I'm going to go to 97. Alright, and then if I do that, I see the sales are going to be $243.02. So $243.02. Now it says, what would you expect the temperature to be if the ice cream sales were $215? So if they're $215, this is my y. So now I'm trying to find out what the x is. So in the y column, I'm going to go up to 215. I think I'll just scroll through here. Oh, there it is. So somewhere between here, between 213 and 217. So about 90.5. Okay, on this one down here, they want you to write the inverse. So if I'm going to write the inverse of this, the first thing I have to notice is that there's an f of x here, and this f of x has to be changed to y. So y equals 2/3 x plus 1. Now, to do the inverse, I now need to switch the x and y. So I'm going to do that. So now it's going to become x equals 2/3 y plus 1. And then I'm just going to start solving for y. So minus 1, minus 1. That gives me x minus 1 equals 2/3 y. I'm going to multiply by the reciprocal, so times 3/2. Whatever I do on one side, I'm going to do on the other side, so 3/2. I'm going to distribute this. So now what I end up with is I end up with y equals 3 over 2x minus 3 over 2. Okay, now to write an inverse notation, we got to use that inverse notation. And then I'm just going to rewrite what I had. So 3 over 2x minus 3 over 2. Not much room there to do your work. Alright, on this one here, you'll notice there isn't an f of x. They already put the y there for you. So the first thing I'm going to want to do is I'm going to want to switch the x and the y. So now this is no longer y plus 3, it's x plus 3 equals 2y. Alright, so hopefully now you notice the only thing I have to do here is I have to divide by 2. So divide by 2, divide by 2. Remember there's a 1 right there. So what I end up with is y equals 1/2 x plus 3 over 2. But again, to write it in that inverse notation, it needs to look like this. Okay, on the next one, they're giving me a line. They want me to write the inverse, and then they want me to graph the line. So when it says determine the equation of this, this is your inverse. Okay, so I have 2x plus 1, f of x equals, so I'm going to change this f of x to y, so y equals 2x plus 1, and then remember, now I got to flip these two. So now it's x equals 2y plus 1, I'm going to subtract 1, subtract 1. That gives me x minus 1 equals 2y, divided by 2, divided by 2. Remember there's a 1 right here, so we end up with y equals 1/2 x minus 1/2. And again, you need to write it in that inverse notation, so 1/2 x minus 1/2. Okay, they also want me to complete the table of the original, and then I still need to graph it. So they give me some points here, so I'm just going to use these. So -2, -3. I also have -1, -1. I have 0, 1, and I have 1, 3. So to do the inverse, I'm just going to flip them. So -3, -2. Well, if you flip these, they'll be the same. So -1, -1. 0, 1 becomes 1, 0, and 1, 3 becomes 3, 1. Alright, now remember, everything reflects over that line y equals x. So I'm going to draw that line, and I know that everything has to reflect over that. So I could plot these points. I've got a -3, -2. Okay? I've got a -1, -1, still right here. But then also notice how I can just reflect the points over the line. So there, 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 there. Okay, so that's my new line. Excuse me. Alright, so now I'm going to draw my line. Do the best I can here. And there you have it. Now, here they want me to find out what f of -1 is. So because this is written in inverse notation, I could just go to my calculator and type in this inverse here. Go to my table, and I'm going to look for -10, and I get -5.5. Okay, on the next one, they want me to prove these using composition. Now this is mostly a pre-AP question. The composition was for pre-AP. And if you are pre-AP and watching this, please make sure you know how to do this. Okay, so what I'm going to do is I'm going to input each of them. Now they're telling me g of x is the inverse. I know these are inverses of each other. So instead of using that f of -1, ignore that right there, they're using a g. Okay, so what I'm going to do is I'm going to substitute each of these into each other. So I'm going to start with the f. I'm going to start with the f one. So I have 4. And then instead of the x, I'm going to put this whole thing in. So x plus 1 over 4. And then -1, -1. Okay, a quick way to do this would just be like that. Just cross those out. So now what I have is x plus 1 minus 1, which is just an x. That's perfect. That's what I want. Now I'm going to do it again, but this time I'm going to start with the inverse, the function g. So function g, I already have an x right here. So I'm going to put this whole thing in for the x. So 4x minus 1. And then I got to put plus 1. So plus 1 over 4. Okay, well this all cancels out. That's 0. So that leaves me with 4x over 4. And then those cancel out, so I'm only left with x. And that's perfect. So if they're an inverse, they're each going to equal x. Alright, on the other side, I've got some more linear regressions. Now this first table is a little weird, y'all. It kind of continues. So notice how the time is here, but understand that it continues right here. Same thing with the depth, it's here, and then it continues here. So it's a lot of values, y'all, but you have to type it all in. You have to, you have to, you have to. You cannot just type in a few of them. Alright, so I'm going to start typing all these in, and I'm just going to rewrite over what I already had. So 0, 30, 60, 100, 140, 180, and then I'm going to have 210, and 280, 330, 360, and then 390. Okay, then I'm going to come over here, I'm going to type these in, and I'm going to do my depths. 240, 225, 203, 189, 180, 164, and just continue to the other side of the table. And then what I would do is make sure they line up, y'all. You need to make sure there's nothing like here. Like say you have a number here, okay, and there's nothing matched to it. See how there's nothing matched? You're going to get an error message. So make sure that when you do put everything in that it's, you know, how it needs to be. Okay, I'm going to spot check it just to make sure I'm okay. I got a 210 and 155. That matches up to this on the table, so that looks good. And then I've got a 100, 189. That's looking good. Okay, so now I'm going to do my lin reg. So stat, calc, lin reg. And here's my equation. So again, I'm going to round to the hundredths. So I have y equals. I have point, there's a 9 there, so that 5 rounds up to a 6. Plus, and there's a 2 here, so that 5 stays the same, so 132.75. Now, they want to know the coefficient of determination. And remember, y'all, that is going to be that r squared. And they want me to round it to the nearest hundredth. So there's the r squared. In the thousandths place, there's a 1, so this will stay 0.10. Okay, now it says, using the function found in part 1, determine the diver's approximate depth at 300 seconds. Okay, so first of all, I need to understand that 300 seconds is the x. So when I'm looking for the depth, I'm looking for the, I need to know what the y is. Okay, so again, you have to put this into y equals. So I'm going to put this into y equals. Okay, and I'm going to go to my table, and they want to know what the depth is at 300 seconds. So I'm going to go to second window, tell my table to go down to 300, and it's 360.75. So that will be the diver's depth at 300 seconds. So 360.75 feet. Then it says, determine the time it'll take the diver to reach the surface. Let me just make sure I put this in right. Okay, so now I'm going to determine the time it'll take the diver to reach the surface to the nearest second. Alright, so here, the surface is going to be 0. So if I come here,